Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about how to find a limit of a rational function, in other words, one with a fraction in it, that if we try plugging in the x value gives us 0 in the denominator and a different number in the numerator. So in this case, we have the function f of x equals 2x over x minus 5. This is a rational function, a ratio of two polynomials, and we're considering the limits to the left, to the right, and the overall limit of this function as x approaches 5. And notice that if we plugged in a 5 in the denominator, we would get undefined. In other words, the function, if we evaluate it at 5, the function is 10 over 5 minus 5, which is 0. Which is undefined. Okay, also notice it's not 0 over 0, where we can often simplify by factoring and canceling common factors. So what do we do? Well, in the case of a rational function, if the denominator is equal to 0 and the numerator is not, then you know that you're going to have an asymptote, a vertical asymptote, if you can't simplify the expression and cancel out the factor that causes 0. So that means that from the left and the right, this function is either going to positive or negative infinity. So as x approaches 5 in this case, either from the left or from the right, we know that y is going to be going off to positive or negative infinity. So figuring out which one is really just a matter of checking some values. So for each one of these, I'm going to make a little chart. So for part A, since we're talking about x approaching 5 from the left, we're talking about numbers less than 5. So for x approaching 5 from the left, we're going to figure out what x and f of x to look at here. So when x is to the left of 5, it might be something like 4, 4.5, 4.9, 4.99. And what we need to do is to plug into 2x over x minus 5. So for example, if we plug 4 in, we're going to get 8 over negative 1, which is negative 8. And if we plug 4.5 in, we're going to get 9 divided by negative 0.5, which is negative 18. And if we plug in 4.9 for x, we're going to get 9.8 divided by negative 0.1, which is going to be negative 98. And plugging in 4.99 for x, we get 9.98 divided by negative 0.01 equals 998. And so we can see a trend. The f of x, the y value, is getting very, very large in the negative direction. So since we know there's only two possibilities, y approaching positive or negative infinity, that means it must be approaching negative infinity. And we have our limit. So I can say that the limit as x approaches 5 from the left of f of x is negative infinity. Now let's look at the limit from the right. From the right means looking at x values larger than 5 and choosing them closer and closer to 5. So 6, 5.5, 5.1, 5.01, and so on. You'll see that when you plug in, you're going to get 12, 22, 102, 1002. These values are getting large in the positive direction. And once again, because of the kind of function we had and because we had a number divided by 0 that wasn't 0 divided by 0, but just any other number divided by 0, we know that the only possibilities are positive or negative infinity. So that means y must be approaching positive infinity. So the limit as x approaches 5 from the right of f of x is positive infinity. Now, in order for the overall limit to exist, it has to be equal from the left and the right. And here we do not have equal limits, so we're just going to say does not exist. Now, if you pop over to desmos.com graphing website or use your graphing calculator and graph y equals 2x over x minus 5, what you're going to see is that at 5, we do have a vertical asymptote. It's evident from the way that the graph behaves there. It's getting closer and closer to a vertical line. And notice that coming in from the left, which would be coming in from the left in a neighborhood of 5, very close to 5. This is going down to negative infinity. So as x approaches negative 5 from the left, y is approaching negative infinity as we predicted. And then over here on the right in a neighborhood of 5, we're going in that direction. As x approaches 5 from the right, y is going upward to positive infinity. So that's consistent with what we found by checking some values. I hope you found this video helpful. If you did, please remember to like it. That helps other students to find the video.